Hey guys, I'm going to take you through a few examples on this crazy factoring worksheet to help you out with it. Page 1 is pretty much all the same, just lots of practice. It is taking out the common factor first and then it will factor a second time. The second page, you're going to do a USubstitution to help you factor. It's a little bit weird, but once you do the USubstitution, it'll look kind of like normal factoring. Page 3 is all the difference of two perfect squares, but some of the difference of two perfect squares look kind of weird. And the last page is factoring by grouping, which would be more of a new concept. So let's start you off with the first page, which is taking out the common factor. All right, I'm going to do this with the mouse instead of at the smartboard, so be patient with me. This may not look the best. My extension cable is at home, and I don't feel like going home and coming back and doing it again and all that good stuff. So we're going to go with this. Let's try purple. So number 1, we have a 3, we have a 3, we have an 18. So the common factor would be, pause, 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 wait. You guys got it? Yes, 3. And then we look for the variable. Nope, nothing in common. So we're dividing 3 out essentially. When you do that, you get x squared plus x minus 6. And this whole page is the same way. It will factor a second time. So we drop the 3 down, and then we do the whole 2 sets of parentheses, put in x in each. So x and x, this is pretty easy factoring. 2 and 3. I'll put the 3 in the front and the 2 in the back. Again, sorry about the penmanship. 3 needs to be positive and the 2 needs to be negative. Use foil to check your work. So let me switch colors here. If we put these two together, we get 3x. Put these two together, we get negative 2x. That makes the 1x in the middle. And you multiply the 3 and the 2 to get negative 6 there with that negative there. So this is it, but it's all this whole page is going to factor twice. Let me undo this. There we go. Let's go down a little bit. The common factor can be fairly complicated. Like look at number 8 here. We're going to look at all of these. Multiples of 13 aren't too terribly bad. Let me flip back to the correct pen. Let's do blue this time. So look at number 8 with me. 13 was always not a bad number for myself because I always thought about 13 cards in a suit. So 13, 26, 39, 52, 52 card pickup, all that good stuff. So 13 is the common factor. So we take a 13 out to the front. Then we look at the variable. We got x cubed. We got x cubed. We got x cubed. Hey, that's in common. Take the whole thing. We look at the y's. We got y cubed, we have y squared, and we have y. So you can only take the smallest amount because it has to have one y in common with each thing. So the common factor is 13x cubed y. So we're going to take that out, and then it should factor a second time. What, y squared here? 3 times makes the 39, so we need a plus 3 and a y. And then finally, minus 4. See, it just broke down to something a lot simpler. So we bring down the 13x cubed, y, and then we do the whole 2 sets of parentheses, put in x in each business. One more. There we go, a little more space there. Y and y, this is easy factoring, isn't it? 4 and 3 plus 4 minus 1. I believe that does it. Yes. Hoo-ha. Answer. Okay, second page. Oh, let me flip back to that. So there's the first answer. There we go. There's the second answer. In case I went too fast. All right. Where's my recording button? Right here. I'm going to pause it for a second. All right, I'm back. Kind of a funny story. The Wiesner left some almonds in the refrigerator, and I stole a couple of them. And when I was talking to you guys, the pieces of almond were kind of scratching in my throat and making it hard to talk. So then I was like, I gotta get some water, so I had to pause it. But don't tell her I took her almonds because she told me not to yesterday, and then she will harm me or something. All right, page 2. Minimize that. And page 2. Okay, USubstitution. So you do a USubstitution. There's only 4 of these, so I'm just going to do one with you. So this kind of jumps at you that these are the same. We have this and that are the same. So we're going to, let me call that U. Okay, so that's my U. So I'm going to get a different color here, back to the pen, and red this time. So U is equal to X plus 1. So now I'm going to have 5, and instead of that mess, I'm going to have U squared plus 12, and instead of that parentheses there, I'm going to have U plus 7. USubstitutions come in handy. When something's complicated, you can substitute U in for it and make it simpler. So we're just going to factor this now. So it's going to be 5 U, 2 sets of parentheses, put an X in each. No, it's 5U in one and U in the other. Okay, 7's a prime number. Let's see, I'll put the 7 here and the 1 there. Everything's plus, so plus and plus. Okay, it's factored. Now I'm going to put the U back in. U is X plus 1. So wherever there's a U, I'm going to put an X plus 1. Let me highlight that with some yellow. So there it is, and there it is. X plus 1's going back into those spots. So pen and red, here we go. So where there's the U, I'm going to put in X plus 1. Now make sure you have parentheses here, so it's 5 times all of U, which is X plus 1. And then plus 7, left parenthesis, right parenthesis. Or no, right parenthesis, left parenthesis. And my lefts and rights mixed up. Hey. And then X plus 1 plus 1. Hey. Now, we simplify this. These simplify out little different levels here, a little more complicated, pretty easy. So we should have X. And of course, 1 plus 1 is 2. Now I distribute here, 5 times X is 5X. And 5 times the 1 is 5, plus the 7 is 12. So believe it or not, the original problem and this problem here should be the same. Pretty darn cool that you can do that. USubstitutions come in handy in calculus to make things that are complicated a lot simpler. All right, everything here on the 3rd page is all about the difference of 2 perfect squares. Okay, we're doing well on time. So it's just difference of 2 perfect squares, but you got to recognize things. Everything here is a perfect square. For example, number 14, you got x squared and x squared. Make the x the 4th, right? So we're cutting the exponents in half. So y to the 10th would be y to the 5th, and y to the 5th. Sorry, my handwriting's not as great. I'm doing this by mouse clicking. So the 5th power times the 5th power makes the 10th power, because when you multiply like bases, you add the exponents. And then the 2 and the 2 make the 4, but this 5 plus 5 is making the 10. When I multiply y to the 5th times y to the 5th, I got y to the 10th. And then, of course, the middle terms all cancel out, so one of them is positive, and the other one is, boom, negative. Going down the page, it's all kind of the same thing, except for maybe some of them aren't difference of two perfect squares until you change something. Like here, that's not the difference of two perfect squares, so you got to like factor out the common factor. That's what this one's like. You got to take out the common factor. This one here factors twice. They're all kind of a little bit different. This one, the 19's a little strange, but you got to recognize this is all one thing. It really is the difference of two perfect squares. So you got a minus this thing, a plus this thing, and then you can do some simplifying from there. Okay, the last page is really the new thing. It's factoring by grouping. These are all kind of the same. It's not super imaginative, although number 28, what's 28 all about? All about. Oh, 28. That's a little different. That's kind of crazy. Um, I think we're just going to stick with the top ones, and then maybe when I get back, if you feel super adventurous, then we can do. Yeah, 27, 28, and 29, actually, you you factor it, and then you factor it again like you did on the previous page. So you are grouping. Anytime you have like pairs of things, you're grouping them together. So here we go. Number 23, what you do is you group these first two together. Excuse me. So I'll highlight this in yellow. And then you look at the next two together. And you're going to take out the common factor. Let's see what color I can do. I'll go back to blue. So we look at these two here, take out the common factor. Well, that would be x squared. What's left over? X plus 3. And we look at the next two in green here. What's the common factor between these two? Like, 4, 8, 12. Oh, yeah, 4, 4. Well, we might as well take the negative with it, too. So we got negative 4. And then x plus 3. You're like, whoa, what just happened there? Oops, I need the highlighter pen. So we know, so the yellow, we took out the x squared, the green, we took out the negative 4, and we're left with x plus 4 and x plus 4, or x plus 3, x plus 3. It's like, hey, those are the same. Amazing. So we factor those to the front. We get x plus 3. And since we're taking the x plus 3 to the front, what's left over when I take this to the front? Oh, x squared. I take this to the front here, the minus 4 is left over. Technically, you're not done here, because it's like, wait a second. This is the difference of two perfect squares like the previous page. So I factor it one more time. So it's x plus 3. And then we got the x. Difference of two perfect squares is easy. Plus 2 and minus 2. So there's all kinds of shifting around there. So now you can see why this is called the crazy factoring worksheet, because it's really crazy. Now have fun with it.